Hi, my name is Anil Emre and I am a Master Management student at TUM Campus Heilbronn. This video is part of the Artificial Intelligence and the Sustainable Development Goals seminar. Today, I want to tackle one of the most debated questions in education technology right now. Can large language models, tools like ChatGPT, genuinely democratize education and help us achieve SDG 4, quality education for all? Or are they creating a new kind of digital divide? In this presentation, I'm bringing together both articles I submitted for this module, the AI solution analysis and the empirical SDG findings. I have structured the presentation around four movements. First, the promise, what LLMs genuinely offer learners. Second, the barriers, who gets left out, examined across three levels: individual, institutional, and systemic. Third, the empirical data on the global AI skills gap. And fourth, my SDG4 fatigue and three concrete policy recommendations. The questions holding all of this together is: can LLMs democratize education, or will they draw a new dividing line? So, let me start with what's genuinely exciting. Look at the numbers on this slide. By July 2023, 63% of American K-12 teachers had used ChatGPT at least once. Of those teachers, 88% say it has had a positive impact on their work. Among students, 79% agree that ChatGPT has helped their learning, and the number of English language AI-related degree programs has tripled since 2017. The educational potential here is real. LLMs offer personalized explanations, instant feedback, writing support, and language practice, all at near zero marginal cost, available 24/7. For learners in resource-concentrated settings, this could theoretically be transformative. And that word, theoretically, is exactly where the story gets complicated. Because accessing those benefits is conditional, it depends on a cluster of prerequisites that hundreds of millions of learners globally simply cannot meet. The first barrier is obvious: a device and reliable internet. Without those, nothing else matters. The second is less well known but arguably more important: language. Research from the University of Oxford, documented in the 2024 AI Index, shows that LLM tokenization introduced a structural language penalty. The same sentence in Vietnamese requires more than twice as many tokens as in English. Across all languages, this ratio can reach 15:1. This matters because many LLM providers charge per token, meaning non-English speakers face both higher costs and worse model performance due to smaller effective context windows. And third, digital literacy. The quality of what you get from an LLM depends heavily on how well you can prompt it, a skill that is not being systematically taught in most schools anywhere in the world. And fourth, Western bias. Research using the Global Opinion QA dataset shows that LLM responses align far more closely with the values and perspectives of Western countries than with those of Global South. These are not neutral tools. They encode the worldview of the people and data that built them. Now let's zoom out to the industrial, to the institutional and systematic level. Look at the chart on the left. In 2023, 90% of large American high schools, those with more than 1,200 students, offered foundational computer science courses, but only 41% of small schools did. Suburban districts, 67%, urban and rural areas, 55% each. These are domestic gaps within one of the world's most technologically advanced countries, and they mirror the global north-south divide. At the systemic level, three structural problems stand out. First, the brain drain. By 2022, 70.7% of newly graduated AI PhDs in North America went directly into industry, compared to roughly equal splits a decade earlier. The pipeline of qualified AI educators is being depleted at exactly the moment it's most needed. Second, curriculum inequality. China has fully implemented AI curricula across primary, middle, and high schools. Germany and United Nations are still developing theirs. And for most of sub-Saharan Africa, as the UNESCO survey shows, there is either no curriculum or no data. That absence itself is a finding. Third, investment concentration. In 2023, generative AI attracted 25.2 billion in private investments, nearly 9 times the 2022 figure. But this capital is overwhelmingly concentrated in the United States, the United Kingdom, and China. The countries that most need educational transformation are not the destinations of the investment wave. So, this brings me to Article 2, the empirical analysis. And I want to highlight one observation I think is underappreciated. The chart on the left shows AI job posting as a percentage of all job postings in 2022. From Lightcast data in the AI Index 2023, the United States leads at 2.05%, Canada 1.45%, Spain 1.32%, and Germany 0.98%, and Italy 0.72%, and New Zealand is 0.45%. These are the measured countries. The Lightcast datasets only covers countries with developed online job posting infrastructure. Sub-Saharan Africa, most of South and Southeast Asia, and large parts of Latin America are simply absent. On the right, you can see LinkedIn AI skills penetration rates, how intensely AI skills appear in workers' profiles relative to the global average. India leads 2.75 times the global average. The USA at 2.22, and German 1.90, and the Canada 1.67, and the United Arab Emirates is 0.98%, so below the global average. And once again, the regions furthest from SDG4 are missing entirely from this table. This is core empirical finding I want you to take away. The measurement gap is the skills gap. The countries we cannot measure are the countries being left behind. Their absence from the data is not a methodological footnote, it's the finding itself. So, even in the measured high-income countries, there is a serious supply-side crisis. 81% of American teachers believe AI should be part of foundational education, but fewer than half feel equipped to teach it. And the people who could train those teachers are increasingly leaving. The reverse flow from industry back into the academia has almost stopped. Only 7% of new AI faculty in North America came from industry in 2022, down from 13% in 2019. So universities are hollowing out their AI teaching capacity at exactly the wrong moment. The curriculum picture reinforces this asymmetry. China fully implemented at all school levels. Germany and United States still in development, and Sub-Saharan Africa and much of Latin America, no data and no curriculum. So, SDG4 targets 4.4 asks us to substantially increase the number of young people and adults with relevant digital skills, including teaching skills for employment by 2030. On the positive side, there is a real progress. AI job demand is rising in every measured country. AI program enrollment has tripled, and generative AI tools are accessible at near zero cost. Governments are actively developing AI curricula, but the structural risks are serious. So, the global south is invisible in all major AI datasets. Teachers' readiness gaps persist across all countries. Language tax penalties, non-English speakers at the fundamental level of how the technology works, and the academic AI talent pipeline is draining into industry. Cetra's 2022 analysis predicted exactly this dynamic. AI risks mainly improving education for those with access to costly systems and those who speak particular languages, thereby increasing the digital divide within and between nations. So, the evidence I have reviewed supports that assessment. SDG 4.4 is advancing selectively for those already closest to the goal. Relative disadvantage is widening. So, what needs to happen? I want to be concrete. Three levers need to be pulled simultaneously. First, open and multilingual models. We need publicly funded development of LLMs that genuinely serve low resource languages, not as an afterthought, but as a design priority. The tokenization inequitably I described is not inevitable. It's the result of design choices. Governments should mandate multilingual training data in publicly funded AI research and ensure that public access is not mediated exclusively through proprietary commercial platforms. The second one, teacher capacity at scale. So this means mandatory AI literacy training for K-12 teachers, not optional professional development, but systematic curriculum reform. It also means creating genuine incentives to retain AI researchers in academic roles. The brain drain is a policy failure, not a market inevitably. So UNESCO is well positioned to coordinate an international teachers certification program in AI education. The third one is equitable digital infrastructure. So public investment in connectivity for rural and low-income areas is prerequisite for everything else. And critically, as Cetras argues, governments and civil society must maintain meaningful control over the learning data collected from the students. If we allow big tech to own the infrastructure of public education, we hand them a structural advantage that cannot be undone. Yeah. So, conclusion. Let me close with three sentences. LLMs are not neutral. Language-based tokenization inequality and Western training data systematically advantage already advantaged learners. The technology is not the problem. The conditions of its deployment are. The measurement gap is the skills gap. Sub-Saharan Africa and Global South are invisible in AI datasets. Their absence from our data reflects their exclusion from the AI economy and from the educational transformation that LLMs could, under better circumstances, provide. And governance determines the outcome. So whether AI advances or undermines SDG 4 depends not on the technology itself, but on the choices made about who get access, in which language, and taught by whom. The answer to our central question, grid equalizer or need dividing line is not yet settled. It depends on us. And thank you.